Hello guys, I hope you are doing good. Welcome to Java Gurukul. I hope you liked my last video and today I'm going to tell you about the Java virtual machines architecture. The reason for choosing this topic is that recently I took some interviews and I found most of the candidates were not clear about this concept, but let me tell you it is very important. So let's continue with it. Before start virtual machine, we should know the types of machines. The first one is physical machine, which is physically present like a calculator. The another one is virtual machine, which is not physically present but do all the calculations like a physical machine. Now the types of virtual machines. The first one is hardware based virtual machine. The second one is application based virtual machine. What is hardware based virtual machine? See the diagram. When we have one physical machine and we create several logical machines on it for proper utilization of a physical machine or computer, that is called hardware virtualization. Application based virtual machine. Application based virtual machine is a computer resource that uses software instead of a physical computer to run programs and deploy applications. Each virtual machine runs its own operating system and functions. For example, we have a high level code which will send to a virtual machine and then it will convert into a machine level code. What is Java virtual machine? As we all know, it is responsible to run a Java program line by line. JVM is a part of JRE and JRE is a part of JDK. What JVM do? JVM accepts class file as an input and convert it into a machine code. How JVM architecture helps JVM? See the diagram. We are going to discuss its all components one by one. There are three basic components of JVM. The first one is class loader subsystem. This is the first component. Second is memory area. It has 5 components. Third one is execution engine. It has 3 components. First, we are going to discuss class loader subsystem. It helps JVM to load the .class file into memory area. See the figure. It performs 3 activities. First one is loading, linking and initialization. There are 3 types of class loaders. First is bootstrap class loader, second is extension class loader, and the third one is application class loader. Now we perform the first activity, loading. In loading, for example, we have a customer.class file which became an input for the class loader, and the what class loader will do. It performs some activities like it will check fully qualified class name, it will check class, constructors, methods, variables, information. It will also check constant pool information and also check fully qualified parent name. Then it will convert and store it into a method area in the form of binary data. Now the second activity is linking. Linking consists of another 3 activities. The first one is verification, preparation and resolution. In verification, it will check binary representation is correct or not. It is compiled by a valid compiler or not. It will check bytecode verification, and if fails, it will generate verify error. In preparation, it will allocate memories for class level static variables. It is also assign default values to variables. In resolution, it will replace symbolic references to the original references from method area where dot class is already loaded in the form of binary format. Third is initialization. In this, static variables assign original values and static block will be executed. If any problem occurs during loading, linking and initialization, then linkage error will be generated. First is loading, linking and initializing. Now we have to know what approach followed by class loader subsystem. Just focus on the diagram. I am going to explain it. The class loader subsystem follows the delegation hierarchy approach. In this diagram, application loader delegates the class request to extension loader, and extension loader delegates the request to bootstrap loader. Bootstrap loader searches it into bootstrap class path. If not found, then delegates it back to extension loader. Extension loader searches it into a class path, but if not found, then delegates again to application loader. If not found in any class path, then class not found exception will generate. Now we have to discuss three class loader paths. The first one is application class path. The current folder where you are working, it will search into that folder. Like you are working in a D drive, my Java program or my Java folder / core Java program. Another is extension class path. It will search into where the Java is by default installed, like C, program files, Java, JRE, library and ext folder. In bootstrap class path, it will search it into where the Java is by default installed, like C, C program files, Java, JRE and main library folder. If requested file not found in any class path, then class not found exception will be generated. Now we have cleared our first component, class loader subsystem. In our next video, we will discuss memory area, which have 5 components. Third one is execution engine, which have 3 components. So subscribe my channel and wait for my next video where we continue it. Bye bye.